Hello guys, this is Abhijit. Today I will explain you a small PDF that I have taken from this website www.examlist.com. So this PDF is concerned for students who are preparing for IIT JAM Physics. Okay, and in today's class lecture series, I'll explain you the minimum mathematics that you must know before starting undergraduate physics. Yeah, there is a particular set of mathematics that you must know before the start of your BSc Physics, like differentiation, integration, differential equation, and their applications. Although you might have studied this in your plus 2, but we'll explore these topics here in more details. Okay, so the prerequisite for this lecture is given here. So you must be good at your coordinate system, vectors, calculus, a bit of kinematics, and if you are weak in these portions, you can also refer to these notes free of cost. You'll get it here in www.examlist.com. Okay, so let us start today's lecture. Okay, so today we'll understand about differentiation. Now, what is differentiation? Differentiation is nothing but a measure of slope. So measure of slope of what? Slope of a function. Okay, slope of a function. So let us first understand what you mean by function. Let us understand what is the meaning of function. Okay, so let me give you an example. Consider a function where you can write y is equals to x. Okay, this is a function that says that for each value of x there is a value of y and they are same, and this can be also written as y. Since y is a function of x, it can be written as y as a function of x is equals to x. Okay, let us try to draw the graph. Let me draw y-axis. So this is my y-axis. Okay, and this is my x-axis. Let me label them. So this is y and this is x. Okay, let us try to understand what this equation is saying. This equation is saying that when the x is 1, y is 1. Okay, so when the value of x is 2, the value of y is also 2. So when the value of x is 3, the value of y is also 3. So you can easily plot this graph. When x is 1, y is 1. When x is 2, y is 2. So your first point is somewhere around here, second point is somewhere around here. Now if you go on plotting these points, you will get a line like this. Okay, you'll get a line like this. So this line is your y equals to x. This line shows that for each point of x there is a point in y and both are same. Okay, so this is a graph of a function y is equals to x. Okay, so why are we using y and x? It doesn't matter. You can also write a function like a. So you can also write a function a. Okay, a is a function of b, so it is b. So and this is equals to b. Okay, so in this case what you have to do is you have to draw the same graph. Okay, you have to draw the same graph and the levels will change. So the levels will change. Here instead of y I have a, and instead of x I have b. The thing is same whatever you do. Okay, so this is a graph number 1. Let us try to understand another graph. Let me explain you a graph like when I write y is equals to say 2x. Okay, y is equals to 2x. This can be also written as in more general form. Since y is a function of x, what do? So we write y is a function of x. So why do we write this part? Why do we write this bracket x? So this is to indicate that this particular y depends on x. Okay, so and this time it is 2x. Now let's try to plot this graph. So what the equation is saying, so when the x is 1, the value of y is 2. So when the value of x is 2, the value of y is 4. When the value of x is 3, the value of y is 6. So we can plot this graph. So let me draw y-axis, and then I can draw an x-axis. Okay, let me label them. So this is my y, and say this is my x. So when x is 1, so when the x is here, so when the x is 1, y is 2, so somewhere around here. Okay, the point is here. So when the x is 2, so when the x is 2, here we have x is 2. Okay, so my y is 4, so it will be somewhere around here. Okay, somewhere around here. So you can get a graph, and the line will be like this. Okay, the line will be like this. So now you can easily see the difference between this graph and this graph. The difference is the angle of inclination. Okay, the angle of inclination with respect to x-axis. Here the angle is less, somewhere around 45 degree. Here the angle is more, so more than 45 degree. Now let us try to understand this more intuitively. For a moment, just forget this. Just forget this part. Let me rub this part then. Okay, for a moment, just forget this coordinate. For a moment, just forget this coordinate. Imagine there are no coordinate. Okay, and treat it just as a line. Okay, treat it just as a line. This part too. So for a moment, just forget there is any coordinate and just treat it as a line. Okay, or you can think of this as a ladder. Okay, yeah, that will be better. You can think of this as a ladder. So this is one ladder and this is another ladder. Now consider two persons, A, okay, and another person is B. Okay, now both want to climb this ladder. Okay, they both want to climb this ladder. Now can you intuitively guess for whom climbing this ladder is going to be tough? It's B. It's B. A can climb easily. Okay, it's because its slope is not more, it's inclination. So whenever I'm saying slope, I mean the angle of inclination. Here the angle of inclination is less, here the angle of inclination is more. So what is slope? So we have already discussed about function. Now let us discuss about slope. So what do you mean by a slope? Okay, so what do you mean by this particular slope? So slope has two meanings. One is intuitively you can think of slope as angle of inclination. Okay, so consider this is a mountain and this is another mountain. So climbing this mountain is easier, but climbing this mountain is a bit difficult. You might slip again and again, but you won't slip here because the angle of inclination is not more. Now this is definition of slope. Point number one is slope is angle of inclination with respect to the x-axis or with respect to the ground. Okay, now mathematically when you look at this line and when you look at this line, there is something that there is a number that indicates something about slope. Can you guess that number? Yeah, this here, the 2. Yeah, this 2, and here the number is, when I write y equals to x, here the number is actually 1. Okay, so these are the numbers that are connected to slope. Here the 1 is connected to slope and here the 2 is connected to slope. So somehow when you write a function of y in terms of x, the number that multiplies the x is slope. So in general, if I write a equation y equals to say x, but I have multiplied a number m, this m is slope. So what is slope in your second definition? In the second definition, slope is a number m that multiplies the variable x. Okay, so this is another definition of slope. My question is, how did you get this number m? Okay, how can you get this number m? It's very easy. It's very easy. For example, how about you differentiate? I hope you know a bit about differentiation. How about differentiate dy by dx? So let us see this. Okay, let us see this. So if I differentiate here, if I write say dy by dx, so what value do I get? I get a value of 1. Okay, this is just plus 2 differentiation that we are speaking. And look at this term. How about differentiate this function? So it is dy by dx. So what do you get? It's very easy. You get a value of 2. So now another definition of slope is differentiation of the function. So whenever you do dy by dx, you get a number, and this number is slope. Okay, let me mention a very important point here. So whenever I'm defining slope, I'm always considering straight line equation. Till now I have considered straight line equation. I have not considered complicated equation that contains x square or 2x square. I have not considered it. I have considered linear equations like y equals to x and y equals to 2x. So I hope you understood what slope is. Okay, so let us continue further. So the same definition has been given here. They have tried to explain the value of slope. They did the same thing. They did this 2 graph. Okay, they did this 2 graph that we have taken, and they have explained how slope is this dy by dx. This is how they have explained slope. So you can look up this PDF. Now here they have explained a very interesting thing. So here they have taken a function y is equals to x square. Okay, so the y equals to x square function looks like this. Now when you evaluate dy by dx, you get 2x. Okay, you don't get a number. Now that might seem confusing, that in the previous definition we said that slope is a number, and now we are saying that slope is not a number but it's a function of x. So what is the meaning of this? So this is saying that consider this is one side of the mountain. Consider there is a mountain whose left side is like this. So when you climb here around this part, climbing is very easy. Yeah, you can easily walk. But as you go up here, the climbing is very difficult. Okay, so that means that slope is less here and the slope is more here. Okay, intuitively that is clear. But what is the mathematics that says that slope is less here and slope is more on this part? The mathematics is this. When you differentiate the function, you get the slope as 2x. So what is the meaning of 2x? So as you go forward in x, the slope goes on increasing. Yeah, that is true. You see, here if I go up to this much, the slope is less, but as I move towards in x-axis, the slope is increasing. Okay, the slope is increasing. So conclusion of this topic is, so differentiation can be calculated. Differentiation can be used for calculating slope. Okay, it's a good way of calculating slope. Second is slope of a function can either be constant or changing depending on the function. As we have discussed, here the slope was constant. In this line, whether you calculate the slope here or you calculate the slope here, is going to be constant. Same as for this, whether you calculate the slope here or you calculate the slope up to here, the slope is same. But this particular function that we have seen, this particular function, the slope is not the same. It is changing. Even the equation is saying that the slope is changing. Okay, so this is some application. This is a small application that you will see in physics. It says that slope of a distance time graph. Okay, so how would the distance time slope look like? It will be like ds by dt. Okay, let me write it down. So slope of a distance time graph will be, so consider I make a graph. Say this side I have distance, and say this side I have time. Okay, so let me write them. Say the distance is given by s and the time is given by t. Okay, so you can have any graph. You can have a straight line graph, or you can have a graph like this. You can have any graph that explains something, and ds by dt. Of course, this is the slope. You would say, wow, this is the slope. This is nothing but the slope. But in physics, you know that well, distance divided by time is always velocity. Okay, you already read in your 10th class. This is a 10th class thing. So what do you understand? So you understand that the slope of a distance time graph is what? Is a velocity. Now, continuing further, there is a notation. Okay, this is very important because when you read some good standard classical mechanics book in your BSc, like classical mechanics by Goldstein or by Greiner, you'll see this y dot frequently. This y dot is nothing but dy by dt. Okay, so there are some big equations. So instead of writing dy by dt again and again, you can just write y dot. It makes things short. So just a short notation. Okay, so we have completed our discussion about differentiation, okay, in detail. Now let us move forward and let us see what they have. Next, they have explained about some more calculus, and they have explained, you might have seen terms like this. Okay, this and terms like this. Okay, so they have explained the physical meaning of terms like this and terms like this. So this part of the class we will do in next lecture. Okay, so I'm concluding the lecture by giving you some short conclusion that we have studied here. So this is what you need to remember for today's lecture. Okay, in the next lecture I'll give you a short description about what is the physical meaning of terms like this. This type of terms will appear again and again in your classical mechanics. Okay, so till then I hope you read this note. It's a very beautiful note, and try to understand it yourself. If not, you can refer my video. It's gonna come up next week.